today's class, we will learn about problems on Fourier series. The problem is obtain the Fourier series of the function f of x is equal to e raised to minus x in the interval x greater than equal to 0 less than equal to 2. The solution of this problem we'll see now.
So, problem on Fourier series. Obtain the Fourier series for f of x is equal to e raised to minus x in the interval x greater than 0 less than 2. Solution. So, given function f of x will collect first. So, f of x is equal to e raised to minus x and in the interval 0 comma 2. Now, so we have, so we need to first find. So this is nothing but if you compare, so this is for 0 comma 2l interval. So in general it is 0 comma 2l interval. So therefore we have, so 2l is equal to upper minus lower value, that is 2 minus 0. So which implies l value is 1. So once we get the value of L, so we'll think of the even and odd function now. So therefore, now to check even and odd, for the given function f of x, I will take it as it is, e raised to minus x. So replace x by 2l minus x, or I can say that L value is 1, so I will write it 2 minus x only. Okay, so L value is 1, so instead of 2l minus x, I will write 2 minus x. So therefore x by what here, 2 minus x. So f of 2 minus x is equal to e raised to minus into 2 minus x. So you can see here, so above concept e raised to minus times 2 minus x, if you open also, will not get back again what here, e raised to minus x. So this is what here, this is not equal to what here. So I can say that this is not equal to f of x. So if it is not equal to f of x, what we can say here, so we can give one conclusion that f of x is equal to e raised to minus x is neither even nor odd. It is neither even nor odd. So therefore for such kind of problem, we'll go apply what here, general Fourier series. So what is general Fourier series of period 2l? We'll see now. So it is neither even nor odd means general Fourier series, that is f of x is equal to a naught by 2 plus summation n from 1 to infinity a n cos of n pi x upon L plus here bn also will come, summation n from 1 to infinity bn into sine of n pi x upon L. So where a naught value is, it is 1 upon L integration 0 to 2L f of x dx. Next, a n value is 1 upon L 0 to 2L f of x into cos of n pi x upon L into dx, and bn value is 1 upon L 0 to 2L f of x into cos sine of n pi x upon L. So remember, if it is general, so if you even and odd, 2 upon will come. If it is even, so it is neither even nor odd, at that time general Fourier series, we need to apply this. So one of the important example I can say. So we'll go one by one. We'll find the value of a naught, we'll apply here, an will apply here, bn will apply here, and we'll see. So remember, so while applying, see that the value of L already we have calculated. So the value of, but I will write it, but the value of L is 1 here. So keep in mind the value of L. So wherever L is there, we'll apply the value as what here, L as 1, and will simplify. So therefore we'll go now. So now we'll simplify one by one. So I will work out first a naught. So a naught is equal to 1 upon L. L value is 1. So I will take 1 integration 0 to L. L value is 1 means 2 into 1 is 2. So f of x. So f of x is e raised to minus x into dx. So on integration. So integration of e raised to minus x we need to simplify now. Now integration of e raised to minus 1 upon 1 is 1. Leave it. So integration of e raised to minus x is e raised to minus x divided by differentiation of minus x is what here? Minus 1. Limit from 0 to 2. So on applying upper and lower limit, what happens we'll see. So a naught is equal to this minus sign I will keep outside. So if you apply upper limit, replace x by 2. So therefore e raised to minus 2 minus, replace x by 0. So e raised to minus 0, which is nothing but minus. So this e raised to minus 2, I will write it as 1 upon e raised to 2, and e raised to minus 0 is again 1 only. So or you can stop it here, or else I can say that, so a naught is equal to, on taking LCM and pushing this minus side inside, it will become, on taking LCM first I will take LCM. So it is 1 minus e raised to 2 upon e raised to 2, or I can say that if you push the minus sign inside, it is e raised to 2 minus 1 divided by e raised to 2. So this is the value of what here? A naught. So I can say that, so therefore, so a naught value is e raised to 2 minus 1 divided by e raised to 2. So this is the value of a naught. Now we'll go for the value of an now. So what is an? So an is nothing but 1 upon L, that is 1 upon 1, 0 to 2L. L value is 1 means 0 to 2. F of x value is e raised to minus x into cos of n pi x upon L. So L is 1 means it will become n pi x into dx. So we need to apply what here? One of the important formula which already I had discussed in the some of the important results. So I will go back and I will show you that once again, that e raised to ax into cos bx into dx is nothing but e raised to ax upon a square plus b square. So I will note down this formula once again. So we'll apply that formula. That formula is, so this is our standard formula. So we have our previous result as what here? So if you compare e raised to minus x cos n pi x. So here coefficient of this x is nothing but minus 1. So value of a is minus 1 and value of b is what here? N pi. So therefore I will write down here. So if you compare, so value of a is minus 1 and value of b is what here? N pi. So if you apply this, so what we'll get, we'll see. So therefore an is equal to 1 upon 1, leave it. So it will become e raised to minus x divided by minus 1 square plus n square pi square. So a square minus b square into a. So a value is minus 1. So minus 1 into cos of b value is what here? N pi x plus b value is what here? N into pi sine of n pi x, limit from 0 to 2. limit from what here, 0 to 2. So once we applied this, so we'll go for the simplification now. So what is the simplification? So on simplification, e raised to minus x divided by, so minus 1 square is 1, so 1 plus n square pi square into, so this will be remain minus cos of n pi x plus n pi into sine of n pi x. So now we'll apply finally the upper and lower limit. So what happens, we'll see. So while applying 1 upon n pi n square 1 upon 1 plus n square pi square is a constant, 1 upon 1 plus n square pi square is a constant. Push this e raised to minus x inside first, minus e raised to minus x cos of n pi x, then e raised to minus s will apply to second term also, plus n pi as it is, e raised to minus x into sine of n pi x, limit from 0 to 2. Now I will apply upper and lower limit so that we can get the answer of an. So 1 plus n square pi square. If you apply upper limit, replace x by 2. So what happens, we'll see. Upper limit minus e raised to minus 2 cos of, so if you replace x by 2, so it will become 2n pi on rearrangement, plus this n pi as it is, e raised to minus 2 sine of, x is replaced by 2 means what here, it will become 2 times n pi upper limit, minus lower limit we need to apply, minus lower limit is replace x by 0. So what happens here, minus e raised to minus 0 into cos of n pi into 0 is cos of 0, upper first term second term, plus n into pi e raised to 0 minus 0 sine of n pi into 0 is what here, sine of 0. So you can go directly also, better you go for directly, but here I am giving in detail. So an is equal to 1 upon 1 plus n square pi square. So on simplification, minus whatever terms left, we will write it, minus 2 into cos of 2n pi, but as per the again the values, that is, I will go back. So sine of 2n pi is 0, but cos of 2n pi is 1. We'll apply both this result and will generate the result here. So I have not applied, but here, so this result will become 0, and cos of 0 is 1, e raised to 0 is 1, so we'll get what here, minus into minus plus 1. So sine 0 is 0, this will also vanish. So what left finally? Therefore an is equal to 1 upon 1 plus n square pi square, bracket positive term I will write first, 1 minus e raised to minus 2 cos 2n pi is how much here, 1. So on final simplification, so this I can rewrite it as 1 upon 1 plus n square pi square. So this I will write it as 1 minus e raised to minus 2, I will write 1 upon e raised to 2. Or on simplification, what we'll get finally, an as, an is equal to, if you take LCM, so it will be e raised to 2 minus 1 divided by e square, and this bracket 1 plus, so on taking LCM, so it will become e raised to 2 minus 1 divided by e square into 1 plus n square pi square. So this is the required result, or I can say that an is equal to e square minus 1 divided by e square into 1 plus n square pi square. So this is the value of an, which we are going to apply in the Fourier series. Now once we got a naught an, we need to find Bn also. So how to find Bn, we'll see now. Now to find Bn, so we know that Bn is equal to 1 upon L, that is L is 1. So 0 to 2L, L is 1 means it will be 2. F of x is e raised to minus x into sine of n pi x upon L. L is 1 means it will become n pi x into dx. So again, so here also we need to apply the formula, as we know that the standard formula is integration of e raised to ax into sine bx dx. Formula will be what? Here already we have seen this formula also in the recall, that is e raised to ax divided by a square plus b square into what? Here a into cos of bx, sorry, sine of bx, this will be sine of bx minus b into cos of bx. So this is the formula, so we'll apply in the above situation. So what is the above here? So if you compare, the value of a is minus 1, the value of b is what? Here again n pi, so bn will become, so therefore bn is equal to 1 upon 1 is 1, leave it. So what happens here, bracket value of a is minus 1 means e raised to, apply here, e raised to minus x divided by minus 1 square plus b square, b is n pi, so b square will come out here, n square pi square into a value is minus sine of b value is n pi into x minus b value is what? Here n pi, cos of b value is what? Here n pi, and already we have x there. So therefore limit from 0 to 2. So on simplification, bn will become, so which is a constant, I will take outside. So 1 upon 1 plus n square pi square is a constant, and multiply this e raised to minus x. So e raised to minus x, this minus sign, cos of n pi x, again e raised to minus x, here will multiply n pi as it is, e raised to minus x into cos of n pi x. So limit from 0 to 2. So on simplification, so bn will become, so bn is equal to 1 upon 1 plus n square pi square, apply upper limit. If you apply upper limit, so what happens here, minus times e raised to minus 2 cos of, if you replace x by 2 it will become 2n pi minus, so one mistake here, it is sine of, it is sine, so this will become also sine of, okay, this is sine of, this is also sine, so sine of n pi to n pi. So if you apply here, it will become n pi into e raised to minus 2 cos of 2x will be replaced by 2 means 2n pi, upper limit, this is upper limit, minus lower limit. If you replace x by 0, so 0 into n pi is 0, sine 0 is 0, so it will be 0 minus, if you apply here, so n pi, e raised to 0 is 1, cos of 0 is 1, 1 into n pi is what? Here n pi. So therefore on final simplification, bn is equal to 1 upon 1 plus n square pi square. So if you but sine of 2n pi is 0, vanishes, so therefore what left here, minus n pi e raised to minus 2 cos 2n pi is 1, this minus into minus is plus of n pi. So therefore which is nothing but, so on simplification you can find here, so n pi common, so I will take it common, so n pi divided by 1 plus n square pi square, so what left inside here, minus e raised to minus 2 plus 1, which is nothing but n pi upon 1 plus n square pi square. So I will write positive first, 1 minus, but e raised to minus 2 I will write 1 upon e square. Or on simplification it will become, so Bn is equal to n pi divided by 1 plus n square pi square. So on taking LCM it will be e square minus 1 upon e square, or finally I can conclude the value of Bn as, so Bn is equal to n pi into e square minus 1 divided by e square into 1 plus n square pi square. So we'll take this value and apply in the Fourier series. So therefore our Fourier series will become, therefore the Fourier series what here, f of x is equal to a naught value. A naught value is how much here? It is e square minus 1 divided by e square. We have divided by 2, so it will become 2 times e square, plus summation n from 1 to infinity. So a n value is e square minus 1 divided by e square into 1 plus n square pi square into cos of n pi x, plus summation n from 1 to infinity. So Bn value is n pi into e square minus 1 divided by e square into 1 plus n square pi square into sine of n pi x. So this is a required solution of given function e raised to minus x. So which one is neither even nor odd? So therefore we need to apply a general Fourier series of period 2L.